Hello, this is Mrs. Ward, and these are the notes from the appendix, section 7, errors in the algebra used for calculus. So there are two things that we're going to do is we're going to look at the common mistakes that are made in algebra, and then recognize and use algebra techniques that are common for calculus. So the first thing is describe and correct the error. So if you look in your book on page A67 to 72, I think it lists a whole bunch of different common mistakes that are made. You might want to look at that. But when I'm looking at example number 1, they want to know what's wrong with it. In other words, when I went from the left side to the right side, I made a mistake. It's obvious that these two are not equal. And the best way to do it is to correct the error is to see if I'm dividing by a monomial, I should take each term in the numerator and divide it by that monomial. So I would have 2x squared divided by 5x plus 1 over 5x. And when I divide here, the x's will simplify, and I'll be left with 2x over 5 plus 1 over 5x. And that would be the corrected answer. This one is not correct because they just divided this x. They didn't take that 1 into consideration. So that is the correction for the error. Next thing is talking about factors involving negative exponents. So if I am factoring this, I have two terms and I want to factor out the lowest common denominator. Well, this looks very confusing, but if I had something like this, that let's say I made it 3a to the 5th minus, let's say just a to the 7th, and I asked you to factor out the greatest common factor, you would look at the 3 and the 1, nothing in common, so you're not going to factor out a number. And then a to the 5th and a to the 7th, the lowest power between those two would be 5, so I'm going to factor on a to the 5th. And when I do that, I'm left with this 3. I've factored out that a to the 5th. This minus sign comes down. And then to find out, I know I'm going to have some a's left over. And to find out to what power, I would take the exponent here, 7, minus the exponent that I factored out, which was 5. And when I do that, I get 2, so this will be a squared. So that would be the factored form. So I'm applying the same principle here, except for I have this x plus 1 instead of an a, and I have fractional exponents instead of, whole numbers. So I'm going to factor out the x plus 1 because that's the factor that they both have in common. Then when I look at negative 4/3 and 2/3, negative 4/3 is the lower power, so that's what I'm going to factor out. So when I factor out this x plus 1 to negative 4/3, this is gone, and I'm left with just that x. Here's my plus sign. And then I have to ask myself, I'm going to have some x plus 1s left over because this power is higher. And to find out how many, I'm going to take this exponent, 2/3, and subtract what I factored out, which was a negative 4/3. And when I do that, I end up with 6/3 or 2. So this is going to be raised to the second power. And I'm not going to leave it like that. I'm going to simplify it. So here I have this x plus 1 to negative 4/3. And then this will be x. And then when I square this, not making the common mistake, I'm going to have x squared plus 2x plus 1. Now I'm going to combine my like terms. I'm going to get x squared plus 3x plus 1. And I'm multiplying this whole thing by x plus 1 to negative 4/3. That is one version of the correct answer. Or you could write it without negative exponents and make this x squared plus 3x plus 1 in the numerator, and then this x plus 1 in the denominator, and then that would be a positive 4/3. Either one of these is acceptable depending on the directions. So you have to read the directions and make sure it doesn't say anything like no negative exponents. Rewrite the fractions. So this is extremely important when we do conics, which is in chapter 10. So here I have 9x squared over 25 plus 16y squared over 49. You might want to check your note sheets. That should be a 16 if it's not correct on your note sheets. So when I look at this, I see that the 9 is now a 1. So I ask myself, what do I have to do the 9x squared to make it 1x squared? And depending on how you want to look at it, you're either going to divide by 9 or you're going to multiply by 1/9. I think it's easier, since I have a fraction, to show that I'm dividing the numerator by 9, so I'm actually multiplying by the numerator by 1/9, which means I'm going to multiply the denominator by 1/9, because if I multiply by 1/9 over 1/9, I'm multiplying by 1, I'm not changing the fraction. So here, this 9 is understood to be over 1. The 9 simplified, and that's how I'm left with this 1x squared. And then when I multiply here, I'm going to end up with 25 over 9. And that when you have a fraction, the fraction is called a complex fraction. In conics, we are going to leave it as a complex fraction because it's more important than I have the ones here. So we're going to be doing this when we do conics. When I'm looking at this one, I'm going to do the same thing. I'm going to multiply by 1/16, 1/16, and this will end up being 49 over 16. And that would be my final answer for rewriting those fractions. Number 4, I want to rewrite with negative exponents. So all I'm going to do is I'm going to take this and I'm going to bring it up to the numerator level. I'm going to leave the 3x squared there because it's there. I'm not going to put that in the denominator to make it negative. I just want everything. When I'm rewriting with negative exponents, that usually means that I want everything on the same level. So I don't want to have a fraction anymore. I don't want it written as a fraction. So this will be 2x squared minus 1. And then since I've changed the level, I'm going to now raise this quantity to the negative third power. And that's all you have to do for those ones. I'll rewrite the fraction as the sum of terms. Again, here I have 1, 2, 3 terms. So I have a trinomial being divided by this monomial. So I'm going to go term by term. So I'm going to have x to the third divided by x squared minus 5x squared divided by x squared plus 4 over x squared. Especially on a test or a quiz, worth the time to write it term by term to show your work so you know what you're doing. Here, when I simplify, remember you subtract when you divide, you subtract your exponents. So this will be x to the first power minus, here the x squared will simplify completely, so that'll just be 5. And then I can leave it as plus 4 over x squared. Or I can write it as x minus 5 plus 4 times x negative 2. Depending on what I'm doing in calculus, this might be the better format for me to do it because it's a lot easier to take the derivative when my expression is written like this than taking the derivative of this or taking the derivative of this. So this is why we learn how to rewrite these. And if you don't know what derivative means, that's okay, you will. All right, this one, in calculus, it's often necessary to take a simplified algebraic expression and unsimplify it. So I have 7x squared over 10. And then on the right side, I just have this 7/10. So I kind of look at it this way, and I imagine that that's gone because they're the same on both sides. So that means this x squared is equal to whatever this blue space is. So this, the correct answer will be x squared. So when it asks you, when it has an equal sign, it's like you're going to eliminate what's on both sides because it stays the same, so you don't need to worry about it. Oops, that's my dog, so sorry about that. Okay, this is another one where the left side looks like the right side. So I'm going to try and see what I have on both sides to eliminate that. So here I have the 1 minus 2x squared raised to the third. And I have the exact same thing over here. So in order to solve this, I could divide both sides by that, and that kind of eliminates that. So now what I'm left with is x is equal to something. And that's that blue space. So let's call that A for lack of anything else. I can't call it X because I'm already using X, but I'm going to use A. A times, and then you have this 3x squared. So you're asking yourself, what do you have to multiply this 3x squared by to get just this x? Well, I'm solving for A, so I'm going to divide both sides by 3x squared. And when I do that, I get A to equal, and then 1x will simplify, so I have 1 over 3x. And that's what's going to be what goes in that blue box there. So again, what you're going to do when you have problems like this, you're going to eliminate what's common to both sides because it's like you're dividing both sides by whatever that term is or that factor. Okay, so this one you have 1 minus 3x raised to the 4/3 minus 4x times 1 minus 3x. This one has an equal sign, but I can't eliminate because well, I can. I'm going to have to factor this out so I can eliminate it from this side. So when I look here, that 1 minus 3x is what's in common. That 1/3 power is the lowest power. So that makes sense that that's what they factored out. So I'm going to write 1 minus 3x, and I'm factoring out a 1/3 power. So in order to get this one here, I know since this is higher, I'm going to have that 1 minus 3x. To figure out what my exponent is, I'm going to take this power 4/3, subtract the power that I factored out, and I get 3/3, which is just 1. I don't have to write the 1, but I did. Then I'm going to have this minus, and then this is what I factored out, so I'm going to be left with just this 4x. So I'm going to just, this will just keep on coming down. I'm going to keep on writing this. I'm going to have 1 minus 3x to the 1/3. This will end up being 1 minus 3x minus 4x. And when I combine my like terms, I'm going to have 1 minus 7x. And then I'm going to actually write this time. And this is going to be 1 minus 3x to the 1/3. And then I have this question mark that I'm going to call A for lack of anything else to call it. And then here I can see that this matches this. So it's like they divide out, which means that this A is equal to this 1 minus 7x. So that's what's going to go in this. That is going to be the answer. Goes in the box. Okay, this one is a little tricky because now I have these denominators. So when I look at one like this, I ask myself, well, I'm still doing basically the same thing. I see that I have this t plus 1, and then I see here that they wrote it all over common denominator. So I'm going to take the lead from them and write these two over the common denominator. Well, if I look at 7 and 4, my lowest common denominator for those is going to be 28. So I'm going to multiply this by 4. And I'm going to multiply this by 7. So when I do this, I'm going to write, if you don't, well, I'm going to write 4 times 3. I know it's 12. You don't have to tell me that. So this will be t plus 1 to the 7/3 minus, and then I'm going to write 7 times 3. And then this is t plus 1 to the 4/3. And I just made this so it's over a denominator of 28. Well, the reason why I did that is I'm going to look at my numerator and see what I can factor out. Well, I can see that I left the 3 there, so I'm going to factor out the 3, that 3 and that 3, and then I'm going to factor out t plus 1 to the lowest power, and the lowest power between 7/3 and 4/3 will be that 4/3. And what I'm left with is here I factor out this 3, so the 3 is gone, so I have the 4. And this power is more than this power, so I'm going to have a quantity of t plus 1 left. And then to find out what that is, I could take 7/3 minus 4/3 and get 3/3, which means it's raised to the first power. I'm not going to bother writing the 1. Minus 7, factored out the 3, factored out the t plus 1 to the 4/3. And this is all over 28. So I'm going to have 3 times t plus 1 to the 4/3, and then here I'm going to have 4t plus 4 minus 7 all over 28. And if I rewrite that, I'm going to have 3 times t plus 1 to the 4/3. This will be 4t minus 3 all over 28. When I look what I had on the other side originally, I had 3 times t plus 1 to the 4/3. Then I had that blue box over 28. And I'm going to cross out like 3's I have on both sides, the t plus 1 to the 4/3 I have on both sides, the 28 in the denominator of both sides, which means the answer is going to be that 4t minus 3. Okay, that's where I stopped. So I stopped, and we're going to finish up the notes next class. So I hope this helps, and I will see you soon.